So more on lesson 102 with binomial expansions. I already, when we worked ahead, gave you the formula. If you have a binomial, so two terms, it might just be an A and a B, or A might really be 17x to the 5th times y to the 17th, plus something else, or minus something else in there. This symbol that I have here simply means we are going to have a bunch of terms that we add up. And I'll talk more about that in a minute, but we are going to take we're going to do the combinations, and the top number is always going to match the exponent on the original parentheses, and then the bottom number is always going to be one less than the term number. So if I want the first term, then choose a 0, which we'll need to talk about here in a minute. If I want the 7th term, this is going to be a 6 right here, 7 minus 1, and a 7 minus 1 out here. And we also know that these two terms together need to always add up to our original exponent. So that's just what we've said before. Now this sigma notation that you see in there, that's the uppercase Greek letter sigma in that. That means to add a bunch of things. That means you start with whatever they have down the bottom. So we're going to start with R is 1, whatever is listed there, because it says, well, they could have said R is 5, they could have said start with 5. But we're going to start with 1 and keep going till we get to the top number. So I'm going to start at 1, and then 2 and 3, so I'm going to end up with n plus 1 terms, and we already saw that we have one more in the list of things. If we have a plus b squared, we have 3 terms. If we have a plus b cubed, we have 4 terms, and so on. So that just means start at 1 and keep going till we get n plus 1 terms in there. So if we want the 4th term of this, now these are going to be messy, some are going to be pluses, some are going to be minuses inside that parentheses, and they're not going to be just single letters. And so this is just to review some of the messy ones. So since we want the 4th term, we're going to start out by writing down our combinations. Max, what numbers go in there? How many choose how many? How do I set up just the combination part?
It will be 4 on the top.
Uh-huh. And if I want the 4th term, what's going to go in the bottom? Mm-hmm. Then I'm going to take my first term to some exponent and my second term to some exponent, including the plus or minus signs that go with each of those terms. Derek, which exponent do I want to write down first? And what exponent should I put on 2y squared?
It's 3 because it's plus minus 1.
Uh-huh. So it's going to match. Okay, then I need to do what, Addie, for my other exponent?
We need to add up to the original exponent.
Uh-huh. So I need them to add up to the original 4, so that one needs to be a 1. Questions with that much? Okay, then it's just a matter of crunching through the calculations. So we need 4 factorial over 3 factorial, and 4 minus 3 factorial is 1 factorial. That's going to be easy. And then I'm going to have minus 3x to the first. But then if I take 2y squared and cube that, Mateo, what will I have? If I take 2y squared and cube it.
You get 8y to the 6th.
So everybody comfortable with that? Okay, this one's easy to simplify because 4,321 over 321 is just going to be a 4. And 4 times a negative times a positive is negative. And let's see, 4 times 3 is 12, times 8 is what, 96? So I think we've got a negative 96, x, y to the 6th. Questions on that? Okay, now let's expand. So that means all of the terms. And let's do it with this new formula. We're going to be setting things up with those combinations. So my top number in the combinations is going to be 3 for every single term. For my first term, the bottom is going to be 1 minus 1, so it's going to be 0. So I'm going to need to talk about what 3 choose 0 means, and I need to give you a definition for that. And then I'm going to take my first term to a power, my second term to a power, and notice I included the 4, I included the minus sign in there. The last exponent needs to match what I have in the bottom, and the two exponents together need to add up to the original exponent. And then I'm going to have 3 choose 1 with a term, and 3 choose 2 with a term, and 3 choose 3 with a term in there, and that will give me, since I'm cubing it, I will need to end up with 4 terms in there. We've seen that before as we've done expansions. Cubed has 4 terms, so the fourth has 5 terms. Each of these terms is going to have 4a squared to a power minus y to the 4th to a power. And each of the exponents will still follow the same pattern. If I have a 1 down here, I need a 1 over here. They still have to add to be 3, so that means I need a 2. I have a 2 here, my last exponent is a 2. They still have to add to be the original 3, so a 1. And if I have a 3 here, the last one matches that, and I have to add to be the original 3. Going back to the very first binomial expansions we did with Pascal's triangle, first term started at cubed, and then went down squared first, and then we didn't have it anymore. And the last term started off non-existent, and then went up 1, 2, and 3. So you see the consistency with what we've already done. Okay, next thing I'm going to do is to say anything to the 0 is just 1. So I can get rid of that entire parentheses and this entire part, and those are just 1. Now, I know from Pascal's triangle, my first coefficient was always what on Pascal's triangle? 1. So I know that this better be a 1, and this better be a 1, so that it's consistent with what we first learned with Pascal's triangle, right? I've got this on another slide. I'll just do a quick little aside in here. So, if I tried to do 3 choose 0 with factorials, I'd have 3 factorial over 3 minus 0 factorial and over 0 factorial, right? And well, the 3 factorial over 3 factorial would be easy. 3 times 2 times 1 over 3 times 2 times 1. They cancel out, and so I've got 1 over 0 factorial. But I know that from Pascal's triangle, it's supposed to be equal to 1. So I'm looking at 1 over 0 factorial ought to be 1. So we are going to define 0 factorial is just 1. So anytime you have it, Just like something to the 0 is 1, 0 factorial is also going to be 1. So now let's go back to what we're trying to evaluate. So this 3 factorial over 0 factorial we've just figured out is 1. Who can help me out with 4a squared cubed? Robbie, what's 4a squared cubed going to give me? So I don't really need that 1 right there. So 64, a to the 6th. Okay, my next term needs to be 3 factorial over 2 factorial and 1 factorial. 4 squared is 16. A squared squared is a to the 4th. And minus y to the 4th. And then I need 3 factorial over 1 factorial and 2 factorial times 4a squared. Now help me out. Minus y to the 4th squared. Bethany, what will that give?
Y to the 8.
The minus minus is going to become a plus. And then we're going to have y to the 8th. Okay, now let's see. If we've got plus 3 factorial over 0 factorial and 3 factorial, the 3 factorials are going to be 1, and we just defined 0 factorial as 1, so that gives us the 1 that we knew from Pascal's triangle we should have on the last term. And then we have minus y to the 4th cubed. Britt, what do I get if I do minus y to the 4th cubed? It will be minus y to the 12th. Everybody okay with that? So now we just have some cleaning up to do, maybe with the help of a calculator. 64a squared. And let's see, 3 factorial over 2 factorial and 1 factorial, that's just going to be 3. Say what? Oh, thank you, 64a to the 6th. Next term will be 3 times 16 is 48. But we've got that minus 1 also, so a minus 48. A to the 4th, y to the 4th. And then a plus, this is going to simplify to 3. Times 4 is 12. A squared, y to the 8th. And then this is going to be a 1 times the minus, so minus a y to the 12th. Now some things I want you to notice. It has 4 terms like we expected. But these coefficients do not match the 1-4 row or the 1-3 row of Pascal's triangle, because we didn't just have x and y inside the parentheses. So don't expect your final coefficients to match Pascal's triangle. These things up here that we wrote in combination form are what match Pascal's triangle. Also notice these exponents do not all add to 3, 6, 8, 10, 12. Lexi.
I have a question about like the very beginning of the combination. I'm a little confused on how you get the 3, 2, 0. Is it just the 0 part?
Because the formula in general is the exponent n, and then whatever term minus 1. So if I want the first term, it is going to be first term minus 1 is 0.
Oh, okay. Yeah.
Any other questions with that? Okay, let's do still another example here. I've got one more on here. Okay, this one is just find a single term. We don't have to expand the whole thing out like that last one. I like these better. It's a whole lot less work. So this time we want to find the 10th term of something to the 12th power. So what am I going to put just in the combinations? Sophie, what would you put in the parentheses for the combination? If I want the 10th term of something to the 12th. Perfect. So 12, choose 9, since we want the 10th term. Then we're going to copy down our terms, minus 3x squared z, and minus 2a squared w cubed. Aliana, would you help me with my exponents? Which exponent do you want to find first? And what would it be? Okay, so the last exponent would be 9, because it has to match what we just put here at the bottom of the combination. And what about my other exponent? Actually, what should I do for my other exponent? These exponents have to add up to 12. Now it's just going to be a mess to figure out, and I'm going to need you guys to help me out with calculator on this one. I am not going to try to do this in my head. We're going to have 12 factorial over both 9 factorial and 3 factorial. This part, negative 3 cubed, is that going to be positive or negative? So it's going to be a negative 27. And Anna, what about my variables for that term?
It would be x to the 6 and then
And then my next term, is that going to be positive or is that going to be negative, Emily? Negative, whatever 2 to the 9th is going to be. I don't have my 2's memorized that far. And then what about my variables? Lexi, what exponents do I need for the a and the w? So you need to be entering. So final answer, is it going to be negative or positive without the calculator? So I'm going to end up with 2 minus signs. So I know my final answer is going to be positive. So I don't need to mess with entering the minus signs on my calculator. I just need 12 factorial times 27 times 2 to the 9th divided by 9 factorial and 3 factorial, which will then give me some number that you guys are going to find out for me, times my variance. And might I have a volunteer at home unmute and slowly read me that big number so I can write it down? Dylan, you want to read me yours?
3,041,280.
No, that's good. Any thumbs up, thumbs down? Is that what you guys in class are getting? So 3,041,280, and then I can put those variables e to the 18th, w to the 27th, x to the 6th, z cubed. Questions on that stuff? It's like we've been doing it, but we just haven't had a lot of practice with ones this messy. Okay, you guys do this one on your own. We'll check and see if we all get the same thing.